Hello. That's better. Hello. This is my first actual stream where I'm doing stuff. I just gotta, check if the stream is up and running. So, YouTube, and of course, I'm going to search up Keddy.
Crush your interest.
Press this button, and if you check live, yes, I'm live. That's all well and good. Great. So now that we're live, we're going to be watching this video, understanding it, and then we're going to try to make our own version of this. Let's hope that we manage to succeed.
Verlet integration is a fantastic tool to easily simulate simple physics interactions. In the video I did to demonstrate how easy it is to create a very basic physics engine, I used the naive algorithm to find collisions between objects. This allowed to handle a few thousand objects at a reasonable frame rate, but what if we want to simulate way more? In this video, I will present a simple way to greatly improve the performance of the simulation. This is the technique I use in all my projects involving physics, be it Verlet integration or impulse-based solvers.
Okay, so I'm basically making this. Sorry, if you're interested, don't watch this video. I really have no idea what I'm doing. Check out Pez's work, subscribing and liking the video, because I just really love coders.
The aim of the simulation is to minimize the overlaps between objects. Two objects overlap if the distance between their centers is smaller than the sum of their radius. The value of the overlap is computed by subtracting the distance between the objects from the sum of their radius. Then, we move them along the axis defined by their centers. Each object is moved half the overlap. Here is an illustration of this principle applied to multiple objects. In this example, the initial overlaps were quite important. A single iteration is not sufficient to fix them. We can either perform multiple iterations, or we can try to minimize these overlaps in the first place by using substeps, resulting in much smaller objects' movements between physics frames, and thus much smaller overlaps. All of the simulations of this video will be using 8 substeps, meaning that the physics solver will run at 480 Hz. This is how I enable substepping in my code. The naive way of detecting overlaps is to iterate on all the objects and, for each of them, to iterate on all the others. Check the distance and move them apart if they are too close. While valid, this algorithm is very slow because the number of checks to perform is equal to the number of objects squared. This algorithm could be written like this. Let's run a simulation where we continuously add objects and stop it as soon as the frame rate drops under 60 FPS, and see how much objects it can handle this way. As you can see, the simulation can only handle a few objects. What's really inefficient with this approach is that we perform a lot of useless checks between objects that are very far away. In order to vastly reduce the number of collision checks, we have to introduce the notion of space partitioning. One of the simplest structures is the fixed grid. The simulation space is divided in square cells. For maximum performance, I will use objects all having the same radius and set the cell's size to the object's diameter. First, we have to add the objects into the grid. To do so, each object's index is added into the cell above which its center is. At the end of the process, each cell stores the list of its contained objects. Then, to find collisions, we iterate on all the cells and compute the distances between all the current cell's objects and the ones associated to the surrounding cells. To remove any boundaries check, we don't iterate on the cells on the border. This algorithm could be written like this.
Sorry for pausing the video, and I told you I'd just watch the entire video first, but I don't think that he's like put a tutorial inside this video. Now I don't understand any comments because they're all talking about like physics stuff, and I don't understand. Okay, so what I'm gonna do now is he left a GitHub inside, so hopefully I think that maybe wait, so mkdir build, cd build, cmake, okay, so there's no so let me just check these files to see. This might be it. I'm not sure though, so oh man. Sorry. I'm gonna have to cut this stream short. I'm sorry. I know you hoped for like a larger screen where I try to make it. You know what? Let's look for an actual physics engine maker on YouTube right now. Oh god, that's long. And currently I'm working on like a thing. So I'm currently working on Pygame. This is this tutorial by the same guy that I'm working on. It's only 23 minutes, so I'm hoping that maybe we could try to, work on this. So let's get started.
Ready to level up your Python workflows? PyCharm, the only Python IDE you need.
We are spawning an apple that falls down and is physically accurate. And we can go completely crazy with this and just drop a ton of apples and they all fall down.
This is insane. I absolutely love him. Not in that way, but his tutorials are just so good. So let's hope that we can follow along with this tutorial.
Fall down, physically accurate. At least reasonably physically accurate. And yeah,
So
that's
cool.
pretty much it. Let's jump right in. And before we get into code, let's talk about the theory of what we are doing. And the most important thing we have to talk about is the PyMonk library. And the PyMonk library is basically a 2D physics library. So this one can help us to calculate physics in a 2D space. And this library could stand entirely by itself. So you could just run it, not visualize anything, but have all the accurate numbers to calculate some physics simulations. But what we are going to do for this tutorial is we take what's being calculated by PyMonk and then visualize all of this with Pygame. And you really have to be aware that those are two different libraries, and they are fairly independent of each other. So while we calculate the physics in PyMonk, we could visualize them in lots of other libraries. This could be Piglit, this could be Matplotlib, this could be Pygame Arcade. There are lots of different ways. Basically anything that can visualize data could visualize the data from PyMonk. But in our case, we are using Pygame because it's a fairly straightforward library. And I do make the assumption that you already know some Pygame. It doesn't have to be much, just the absolute basics. If you don't know them, check out this video. It explains all the basics you need for this tutorial. But with all of that one done, let's talk about how to simulate stuff in PyMonk. And before we get into explaining anything, we have to install Pygame and PyMonk. So if you're on a Mac, open the terminal. If you're on Windows, open the PowerShell. And to
Okay. Pip install PyMonk. Oh yeah, also if you're wondering, yes, I am a Linux user. Yes, I understand terminal. Thank you. So now I have PyMonk. Yes, I have PyMonk now. Let's
and to install Pygame, you need pip install Pygame. To install PyMonk, you need pip install PyMonk. In both cases, you should be seeing a brief animation, and then you have it installed. This step should be fairly straightforward. And once that is done, you can use them like any other library in Python. So you just need to type import and import the relevant module you want to have. Let's actually talk about how PyMonk works. The first thing we need for PyMonk is to create what is called a space. And a space is just an area where physics is being calculated. So we are basically creating a universe with our own physical laws. And the one physical law that is relevant for us in this case is gravity. So we create a space with a gravity. And also be aware, you have to continuously update this simulation. Otherwise it's just standing still. And inside of this space, we can create physical objects. The first thing we need is a body. And a body is basically a physical body, with one major difference, that this body does not have a shape. So it can accept physics, but
I'm thinking, instead of the apple he showed from the beginning, we could put Among Us. Yeah, I know that meme's outdated, but I like Among Us.
it cannot collide with anything. So we are basically controlling an atom right now. But to this body, we can give a shape, and this would allow it to collide with other bodies. And then when they all work together, you have a physics simulation. And that's pretty much the basics of PyMonk. We're gonna do all of this in code in a little bit. But again, be aware, right now, you would not be able to see anything. To actually visualize all of this, you need another library, which in my case is Pygame. But okay, with all of that one done, let's actually get into some code. So here we have the most basic setup for Pygame. It doesn't really do anything. If I run this, we are getting a screen that can't do anything, it just shows a fairly gray background. And again, check out the other tutorial I mentioned earlier to get the details on all of this. Fairly gray background. Doesn't really do anything.
I understand what this does. So basically, I know he put this, but from his last tutorial I understand what this does. Pygame.init, it starts Pygame. Screen.pygame.display.set mode. What this does is it sets the mode for Pygame and screen size and width, so it's basically a full square. This sets the in-game clock. This is while true.
If I run this,
I think,
we are getting
and,
a screen that can't
for
do anything,
event,
it just shows a fairly
or
gray background.
Wait. So this is for event in pygame.get. This checking for easy input. If event.type pygame.quit, so if you close the game, pygame.quit, so it quits it and sysexit. The reason it does this is so that, because if you have just a window, it crashes and stuff. So we don't want that. So just to confirm, I understand what this means and I'm not just blindly following. So I've got my file opened up here. Import Pygame. Sys. Wait, is there an actual library called sus? Oh, dude, it light up for a second there. Sus.
Anything, if I run this,
Game.init. I think you put thing here. No, you don't. Init screen. Screen equals pygame.display.set mode. Pygame.display.set mode. Then I think put another one. 800 and 800. So if we check here, yeah, it was the same one. This clock dot equals pygame dot time clock. So pygame game no clock time. Wait, let me just check. Yeah, clock equals pygame dot time. You shouldn't have got that in. Ooh, what's this? So, dude, I think the YouTube ads are just checking at this point on what you're doing. I actually have PyCharm installed, I just don't want to use it. So, pygame.quit, if event.type equals pygame. That's the Zelda code. Clock equals. I think pygame.time.clock. Iravate. There we go. So then we establish our game loop. While true.
if I run this, we are getting a screen that can't do anything. It's a basic setup for Py.
For event in pygame.event. I think it's event. No, pygame.event.get. Event.get. Pygame.event.get.
For Py.
And then checking for user input. If event. What's this? Why am I getting an error? What? Dude, there's not even supposed to be an error. Wait. Pygame.get. There we go. If event.type equals pygame.quit. Pygame.quit. pygame.weak dot quit pygame.quit pygame.quit sys.exit fill screen.fill so screen.fill and then we put like we just check 217 217 217 217 217 217 217 bruh. I want a different background color. You can just like take a color from the pygame.ce website, but you know, for now I can just keep it like this. Pygame.display.update pygame.display.surface get surface, right? Pygame.display.update date, so it's updating basically, and clock.tick 120. Yeah, clock.quit 120. So 120. So wait. Oh my god, I keep confusing. But they do rhyme in my defense. Clock.tick. So hey, yo, let me just search up something. How to change name of window in Pygame. I just want to change the name, so my awesome Pygame window is too. There we go. Physics simulation the window. No errors when we close it, which is absolutely wonderful. Great, I'm on cloud
for
9.
Pygame. It doesn't really do anything. If I run this, we are getting a screen that can't do anything. It just shows a fairly great
How
background.
big is this screen? Bro, how big is this screen? Bro, if I run this myself, it takes up this much. I can't even see the code. Yeah, that's how. So
And again,
also,
check out
if you wonder, I'm running on pygame.ce. It's in a series. It's apparently better. Yeah.
the other tutorial I mentioned earlier to get the details on all of this. So let's start simulating physics in this. And the first thing we need is to actually import PyMonk. So in our import line, I import PyMonk as well. And if you want to make sure that you installed PyMonk correctly, just run the code now. And if you do not get an error message, you have installed
Hopefully, please. /pymonk. It's green. It works. We don't have an error. Let's go PyMonk. I love PyMonk.
installed all of the modules correctly. So if Pygame or PyMonk have not been installed properly, then you would get an error message. And sys is being installed along with Python. If this one is giving you an error message, something else has gone horribly wrong. But alright, now we have all the things we need to get started. So the first step we need is to create our space. And this needs to be stored in a variable. I just call mine space. And to create this, we need pymonk space. And it does not need any arguments. So now we
Really? Space equals pymonk dot cap space. So
now we have created a physical
sweet. That little thingy.
universe that can calculate physics. But we have to give it one thing, and that's gravity. So space.gravity. And this one needs a gravity both for x and y. And I'm gonna go for 0.
Okay. Space dot gravity equals
0, and let's say for now 500.
What if we just set it to the Vegeta's chamber thingy? Sorry, I'm a Dragon Ball fan. I just don't know the name of that thing is. What if we just set it to that much gravity? What happens if we run it now? Absolutely nothing. Diddly squaw.
And what this basically means is that this is the horizontal gravity and this is the vertical gravity. And the numbers are entirely fictional. What we are looking at
I'm thinking about Uravati from My Hero Academia.
here is something that looks good. We don't really care how physically accurate this is. But alright, now we have a physical space and we have gravity. There's one more thing we need to do, and that is to update this simulation. And for that, we need space.step, and now we need how fast we want to update this. And in the pymonk example, it's 1 divided by 50, so 0.0.
Space dot step. Space dot step. 1 divided by 50.
0.02, which is a fairly small number. So effectively, we have two loops in our game. We have our game loop for Pygame when it updates the screen. And every time we update our screen, we are also updating our physics simulation. But you still have to be aware, we have effectively two different loops that could be
Wait a minute. That image. Bro. Are you kidding? That's the almost the exact same physics simulation we need. I'm sorry. Like, I'm sorry, I went here. I know that we're supposed to be watching the video. It's just that, wait, let me just check my PyCharm. Yeah, PyCharm. The PyCharm Community Edition. I absolutely love PyCharm Community Edition, so that's good. So yeah.
could be updated independently.
1 divided by 50.
Now we have a basic simulation. If I run the code now, we still can't see anything because
That's because it's a calculatory calculator, and it only, like he mentioned in his video, it sorry, like he mentioned in the beginning of this video, it is a calculator, not a mirror. It is a calculator, not a yeah, Pygame's a visualizer, sorry.
because we haven't created any objects yet. And for that, I'm going to create a new function that I'm going to call create apple. And these are the apples I'm going to drop.
That's a function, am I correct? I'm still like learning. So def, I'm pretty sure it's a function. Create Among Us. Create a move. What the hell? sorry for swearing. Sorry, but like, yeah, we're creating Amogus.
drop later.
We're not
And for now,
creating
this one
them,
only needs one
we're
argument,
Amoguses.
and that's the space. So this space we have created earlier.
Yes, bossy. Space. Dude, what's wrong with my keyboard? Dude, I was just trying the wrong thing.
Here. And inside of this function, we have to create two different objects. The first one is the body. And this is the atom that actually is being influenced by physics. And this is being created with pymonk.body.
pymonk.body. pymonk.body. I love bodies.
If you spell it correctly. And there are different bodies.
Oh, caps control. Caps lock B. Badodi. Bro, what is this? Double body. So
Bodies that you can simulate in PyMonk. The easiest one is a static body. This one just doesn't move at all and it just is.
static bodies, I actually know because I made games in Godot, but very, very terribly. In fact, I have one on my computer. Maybe next stream I'll show it, but like, yeah.
Static body. So this one would not be moving. However, when moving bodies come in contact with it, they would be reacting towards them. So they still have impact on the physics calculation. So when I showed you the example in the beginning, the circles at the bottom, those are static bodies because they don't move, but other physical bodies can still interact with them. The second kind of body is a dynamic body, and this is a body that can be moved. And these are the apples we have created earlier.
In my case, they're not apples, they're amoguses.
And the third one is a kinematic body, and we are not going to create them in this tutorial. But basically what they do is that they can be controlled by the player or by
That is a character body in Godot.
some external code. Basically think of it like this. A kinematic body can move by itself and influence other objects. A dynamic body can only be influenced by outside objects, but it can still be moved. A static body just can't be moved at all. And in our case, our apples are going to be a dynamic body. And for this one, we need three different arguments. The first one is the mass of the object, the second one is the inertia, and then the third one is the actual body type, which in our case is dynamic. Mass should be the easiest one. It's basically how heavy the object is. Inertia means how difficult it is to get it to start moving. And you can calculate inertia in a more mathematical way. In our case, we're just going to use some random numbers and see what looks good. So for our mass, I just go with 1, and for inertia, I am just going to go with 100. So these are our first two
Body 1 and 100. So 100. Okay,
arguments. Now we need to specify the body type. This would be done
I just need to check if the stream's still going on.
with the keyword argument body underscore type.
Body type.
And then we need pymonk.body.dynamic, all in uppercase letters. So now we have an atom that can be
Body type equals pymonk.body.dynamic.
be influenced by physics. And the next thing I want to do
Dynamic. Pymonk.capslock body. There we go.
is set the position of this atom. So body.position,
Body.position.
and this again needs a 2.
Body. Body dot body dot position. Dude, I can't turn off cap lock. Wait. Body. Okay, finally. Dot position. Body dot position.
The tuple, but now I'm going to set it at the middle of the screen. So X is going to be 400 and 0.
400, 0.
So our screen is 800 by 800 pixels wide,
800.
and I'm going to set it at 400, so the middle of the horizontal space, and 0, so right at the top. So now we have an atom in one specific position, but it could not be interacting with anything because it's just an atom. It cannot collide with anything. To get it to collide with anything, we need a shape. And in our case, our shape is going to be a circle. So we are simplifying things quite a bit. And generally think of it like this. Calculating physics is really hard and math intensive. And when we later use our apple, it has a very irregular shape, which would be a nightmare to calculate. So what we do instead is we try to simplify the
Imagine what will happen to a manga.
shape. And in our case, since the apple is fairly round, we just put a circle around the entire apple and simulate collision with this circle, which is going to make
I guess I could put like a rectangle.
everything much simpler. But you could literally just draw a couple of points around the apple and make this much more accurate. So we need PyMonk.circle. And the circle
I think I should just, keep it something simple. Circle. Among Us circle. Yo, nah, this is insane. I would love this. Nice group chat, bro, so I'm gonna keep this.
circle needs two arguments. The first one is the body, so this line here. And then we need the radius of our circle, which in my case, I am going to go with
Shape equals PyMonk.circle.
let's say 80. And this number we have to
80. I just want to run it. And of course, nothing happened.
experiment a little bit with in a bit, because we have to make this as close to the apple as possible. So we basically run the simulation and see how good it fits, and then we make it smaller or larger depending on what we need. So now that we have a body and a shape, we have to add both of these to our physics simulation. And this is space.add and body and shape. And now if we were to run this function, we would have one body in our simulation.
Sorry, I'm not talking, but yeah. Space.add body shape. Why is this not bluing? Space. Dot. I'm gonna run this to see if there's any errors. No errors, so I'm assuming that's okay.
However, again, this would not be visible, even though we have a body and a shape. So the body we are creating could collide with something, but we just wouldn't be able to see it. So we're basically using the force right now. And to make it visible, we need to return something. And what we need to return is the shape. So what we
Return shape. Shape app.
use Pygame4 is to visualize this shape. And wherever this shape happens to be, we are going to draw a circle in Pygame. But by itself, these are two different objects. And all of this is going to happen in a different function that I'm going to call draw apples. And
Draw Among Us. Think space as well? I'm not sure.
And it just needs one argument, which I'm going to call apples. And this is going to be a list because we want to create multiple apples. And in this list, we loop through each apple. So for apple in apples. And inside of this for loop, we just want to draw a circle. And this happens with the normal
What? For Amoguses in Amogus.
the normal Pygame drawing mechanics.
Amogus. Amoguses.
Mechanics. So pygame.draw.circle.
Pygame.draw.circle.
And we need a surface to draw on, which in my case is screen. Then we need a color, which for now I'm
Sorry.
going to just make it black. So 0,
0, 0, 0, 0.
and 0.
Oh god, my thing. Oh god, my thing might crash. Wait. Oh no, my thing's crashing. Okay. Please still be on.
Let me just go to my account now. So how do I check this? Yes, ma'am.
Unfortunately, I no longer have access. Physics engine clear code. Luckily, I'm prepared for these types of situations. I just have to find the video on Google. Please come. Yes, this is it. And I use this thing called SafeShare. Not only is it safe, but like you can watch videos on it. So there we go. Let it do the work. Bada bing, bada boom, and we're watching. Yeah, that was timed up perfectly. It usually takes longer.
The simulation and see how good it fits, and then we make it smaller or larger depending on what we need. So now that we have a body and a shape, we have to add both of these to our physics. So we need to argument pymonk.circle. And the circle needs two arguments. The first one is the body, so this line here. And then we need the radius of our circle.
Oh no, that's
And
too.
we return pi different colors. Then 0. What we want is to take this shape and the center of this shape and have our circle in the same position. And since each apple represents the shape, what we need is apple body dot position.
Apple.body.position.
No, I'm checking it. I only understand the one. So University of Michigan, Ann Arbor.
Oh,
Can you see it now, man?
Position. So this line here will give us
please. Okay, so I'm gonna start this. Please don't be any errors. There's nothing showing up on screen, but I expect that's part of the process.
the center of this shape. Because at the center of this shape, we have the body. And from the body, we can access the position. So basically what we created here in the beginning is going to be passed into our circle as well later on. And then we need one more argument, and that's the radius of the circle. And in our case, this has to be 80, because when we create the circle up here, this is also 80. So I'm just going to stick with 80. And that's basically it, all we need for now.
Please tell me it works. Please. And nothing's showing up on screen, I think.
So I'm just going to stick with 80. And that's basically it, all we need for now. So in here, we created a physical body. And for now, I'm just going to run this create apple function once. And what I want to do is create an empty list that I'm going to call apples. And for now, it's just an empty list.
Amoguses. I'm really going on the amoguses.
Oh no, when you I got the My LED portal thing.
Okay.
And then apples.append and create apple.
Oh man, Monday is fine.
Apples.append. App amoguses.append. Create amogus. The create amogus function.
And it gets space. So we basically create an empty list and we create one apple and pass it into here. For now, it's just a circle.
And put that space.
But we can insert an apple in just a little bit. So now we have a list with one circle inside of it. And this
If it starts, what will happen? Still nothing.
needs to be drawn now. So in our game loop, I'm gonna draw apples and I pass in the apples list.
Covered this wrong place. Control X. He wrote that in Pygame Init. Oh no, wrote that in the right place. So wrote that in the correct place.